The shell of this gun weighed nearly 70 kilograms. After firing, the 50-ton machine would recoil backward and bounce off the ground, not from an explosion beneath it, but from its own recoil. For tank technology, this was the limit of what was acceptable, and yet the British deliberately took this risk, attempting to create a weapon against Soviet heavy tanks. The starting point was one specific day that sharply changed the atmosphere in Western military headquarters. On September 7, 1945, a grand victory parade was held in Berlin. The four Allied powers were celebrating the end of World War II in Europe. American, British, French, and Soviet units marched through the destroyed streets of the German capital, followed by armored vehicles to show the world the power of the victors. The Americans brought their Shermans and Pershings. The British displayed Cromwells and the new Centurions. The French fielded whatever they had managed to restore after years of occupation. But the main surprise was prepared by the Soviets, and it caused Western observers to tense up noticeably. When the Soviet IS-3 heavy tanks rolled out onto the parade, confusion arose among British and American officers that quickly turned to alarm. Almost no one in the West had seen this machine before. Few even understood that the Soviets were working on anything like it. And yet a colossus was rolling past, next to which Western tanks looked like technology from a previous era. The IS-3 had a distinctive pike nose on the front of the hull, a powerfully sloped frontal plate, and a low, streamlined turret, as if it had been shaped in a wind tunnel. Western specialists immediately began analyzing what they had seen, and the conclusions for London and Washington were unpleasant. The IS-3's frontal armor was 120 millimeters thick, but due to its slope of approximately 55 degrees, it provided protection equivalent to nearly 200 millimeters of steel. The hull sides were protected by 90 millimeters of armor, and the turret at its thickest point reached 240 millimeters of solid steel. The tank was also armed with the D-25 gun, caliber 122 millimeters, capable of penetrating the armor of all Western tanks at realistic combat distances. In the West, this was particularly painful. The newest British Centurion, just recently adopted and considered the pinnacle of engineering thought, had approximately 180 millimeters of frontal armor and a 17-pounder gun. Yes, it was accurate and reliable, but its armor penetration at a distance of about 2 kilometers under ideal conditions was less than 190 millimeters. The older Comet, which still formed the backbone of British armored forces, had about 100 millimeters of frontal armor, less than some pre-war machines. Compared to the Soviet Colossus, the comparison was simply devastating. In the British War Office, a question quickly arose that troubled generals and politicians for months. If the Soviets already had such tanks in 1945, what would they have in 5 years? In 10? Relations between the recent allies were deteriorating rapidly. The Iron Curtain was slowly descending over Europe, and British strategists were forced to calculate worst-case scenarios, including ones where Soviet armored columns swept through Germany and reached the English Channel. An urgent solution was needed, one powerful enough to deal not only with the IS-3, but with any machines the Soviets might create in the coming decade. The conventional path of gradually upgrading existing tank guns was unsatisfactory. Even the best 90 or 100 millimeters gun could not guarantee penetration of such thick and rationally sloped armor. Something fundamentally different was required, something that had never been mounted on a tank before, something so large and powerful that the very idea sounded on the edge of absurdity, and yet the British decided to make that absurdity a reality. Thus began the story of one of the most extraordinary anti-tank projects in the history of armored vehicles. In August 1950, the British War Office officially formulated the requirements for a new anti-tank system. The specification was tough and nearly impossible to fulfill. The gun had to penetrate 152 millimeters of armor sloped at approximately 60 degrees at a distance of 2,000 yards, roughly 1,830 meters. This combination of thickness and angle corresponded to the protection expected of next-generation Soviet tanks, and possibly even exceeded it. Engineers at the Royal Ordnance Factory in Woolwich quickly concluded that no existing British gun met these requirements. The 17-pounder was too weak. The newer 20-pounder also failed to deliver a confident result. Even the powerful 120mm gun being developed for the heavy tank Conqueror might prove insufficient against future Soviet machines. A completely new gun had to be created, of a caliber that even experienced designers were initially reluctant to believe. Calculations and preliminary tests showed that the only option that realistically met the requirements was a gun of approximately 180mm caliber firing hesh, high explosive squash head, ammunition. This type of projectile worked differently from classic armor-piercing rounds. It did not penetrate armor by kinetic energy. Upon impact, the plastic nose filled with explosive material flattened against the surface, after which detonation occurred. The shock wave traveled through the steel and blasted dangerous spall fragments from the inner surface, which flew around the fighting compartment, killing the crew and destroying equipment. Work began without delay. In December 1952, the caliber designation was officially changed from 180 to 183 millimeters to reflect the actual bore size. The final version received the designation L401 and became a true giant in the world of tank armament. The barrel length was approximately 7.3 meters. It protruded forward farther than the length of a passenger car. The gun itself, with its mechanisms, weighed about 2.8 tons, roughly equivalent to 2 small automobiles. The Hesh shell was also a monster. Reports cite weights ranging from 65.8 kilograms to 72.3 kilograms. Loading was made separate. First, the projectile itself was loaded, then a separate brass cartridge case with the propellant charge, which weighed another approximately 31 kilograms. The complete round stood nearly 1.5 meters tall and resembled a small rocket more than a tank round. The next task was to find a chassis for this barrel. 4 concepts were considered. First, a classic tank with a fully rotating turret and heavy armor. Second, a self-propelled gun with a limited arc of fire but strong frontal protection. Third, a lighter design with limited or full turret traverse. Fourth, a completely unarmored self-propelled mount. Ultimately, the second option was chosen, a compromise between crew protection and technical feasibility. Initially, the plan was to mount the gun on the chassis of the new heavy tank FE 214, later known as the Conqueror. The gun-armed version was to be called FE 215 and was planned to enter service in the mid-1950s. But the Conqueror was still being developed, and there was no ready chassis for testing. Waiting meant losing months, if not years, and the military needed to understand as quickly as possible what they would get in reality. Therefore, a Centurion Mark III chassis was chosen as a temporary platform. It was already in service, proven and available. This temporary machine was designated FE 4005. It was to serve as a test bed to identify problems with the new gun before installation on the target chassis FE 215. At the time, no one fully understood what surprises would come from trying to mount such a gigantic gun on a tank platform. But this soon became very clear. In the most spectacular fashion, from the very beginning, it was clear that mounting such a gun on a Centurion was an experiment with many unknowns. 2 different prototypes were therefore built and the approaches compared. They were called Phase 1 and Phase 2, and each represented its own solution to the task of mounting the 183mm monster on a 50-ton machine. Phase 1 was open, essentially without crew protection. The gun sat on a simple platform, allowing the barrel to be elevated approximately 10 degrees upward and depressed 5 degrees downward. Engineers feared the recoil could literally overturn the machine when firing with a large traverse angle, so strict traverse limitations were built in from the start. This version used a concentric recoil system. A cylinder around the lower part of the barrel was meant to absorb some of the firing energy and reduce the risk of structural failure. The most unusual element of Phase 1 was a revolver-type ammunition feed, a drum, like a giant revolver, holding 5 ready rounds. This was meant to ease the loader's work. Lifting approximately 70 kilograms by hand in a cramped fighting compartment was a task near the limits of human capability. The mechanism would rotate to bring the next round into the loading position, theoretically improving the rate of fire and reducing crew fatigue. Phase 2 looked more like a conventional tank from the outside. Instead of an open platform, it had a closed turret protecting 4 men from shell splinters and small arms fire. However, the armor thickness of this turret was only about 14 millimeters on all sides. For comparison, the standard Centurion turret had approximately 150 to 200 mm of armor. The FE 4005 box was thinner than any tankman would wish, but this was a consequence of physics. Making the armor thicker would push the machine's weight beyond 50 tons, which the Centurion chassis could not handle without radical reworking of the suspension and powertrain. The crew had to accept an unpleasant reality. Their protection was a thin metal shell that would at most stop splinters or a machine gun burst, but would not survive a serious hit. In the closed turret of Phase 2, 4 men worked, the commander, the gunner, and 2 loaders. The revolver feed was abandoned. It did not fit in the limited space. The entire burden of loading fell on the 2 loaders, who had to manually lift and ram first the shell and then the heavy cartridge case with the propellant charge. The rate of fire was about 2 rounds per minute. The ammunition load was limited to 12 rounds. Due to the confined space, the turret traverse was also restricted to a narrow arc. The machine could not engage targets to the sides like a normal tank, and any change in the direction of fire required rotating the entire hull. This made the FE 4005 more of a mobile artillery position than a fully capable tank for mobile combat. Both versions received another key element, a ground anchor mounted at the rear of the hull. Before firing, it was to be pressed into the ground to stabilize the machine and reduce recoil and rocking. The engineers understood perfectly that without such a support, the recoil could produce unpredictable consequences. By April 1952, Phase 1 was ready for trials. Phase 2 was considerably delayed and would not appear until many months later. A curious detail, special sights were planned for these machines, but they were never manufactured. Instead, the TZX-12, a sight was used, optics that had previously been fitted to German Panthers during World War II. Equipment from yesterday's enemy unexpectedly proved useful in Britain's strangest armor project. The time came to test whether this whole construction would actually work, and whether years of engineering work would turn to scrap metal at the first shot. Firing trials were to reveal the real face of the 183 mm gun and its effect on the rest of the machine. The results exceeded the boldest expectations, but not necessarily in a good way. In June 1953, initial firing trials of Phase 1 of the FE 4005 began at a British test range. Observers, engineers, and technicians gathered at a safe distance to see what would happen when the largest tank gun in history fired its shell for the first time. Nobody quite knew what to expect. No one had ever mounted such a caliber on a tank chassis before. The first shot, fired without the ground anchor, immediately revealed the scale of the forces involved. At the moment of firing, the front of the 50-ton machine jumped approximately 43 centimeters into the air, while the rear dipped approximately 25 centimeters. The whole machine rocked like a child's toy, not like a fighting vehicle weighing as much as a loaded freight wagon. Simultaneously, the tank recoiled rearward by approximately 23 centimeters, leaving deep track marks in the earth. Even the most pessimistic forecasts had not anticipated such a reaction. With the anchor, the picture improved but was still impressive. The front bounce was reduced by approximately half. The rearward recoil lessened. The anchor dug deep into the ground and genuinely absorbed some of the recoil energy, but it could not fully tame the forces acting on the structure with each shot. The real problems began when the engineers decided to test firing with the gun traversed to the side. When traversed approximately 90 degrees from the vehicle's longitudinal axis, the effects were the most extreme. The official report used a phrase that sounded almost like a warning. Firing at 90-degree traverse causes movement with extremely high amplitude and rapid vibration cycles transmitted throughout the hull. In practice, this meant the 50-ton machine moved sideways approximately 5 centimeters, as if pushed by the invisible hand of a giant. But worse was to follow. At some point, the gun's elevation mechanism failed completely. On disassembly and inspection, it was found that internal components had deformed and mounting bolts had literally been sheared off by the powerful vibrations transmitted from the gun to the entire structure. Each shot was like a blow from a giant hammer to the entire hull. The metal could not withstand such stresses. The report made a recommendation that perfectly conveyed the seriousness of the situation. It was strongly advised that no crew member be inside the turret during firing until full trials with measuring instruments had been conducted. In plain terms, the machine was so dangerous to its own crew that no one should be inside at the moment the main weapon was used. Despite the problems, work on Phase 2 continued. The machine with the closed turret was completed and also subjected to intensive testing. By July 1955, the Phase 2 prototype had already fired approximately 150 rounds in various tests. The thin turret of approximately 14 millimeters resonated with each shot like a giant metal drum, transmitting deafening noise and vibrations directly to the crew. Anyone who looked inside could quickly understand why the machine behaved so strangely. The fighting compartment was enormous by Centurion standards. It had to accommodate the massive breech, the mechanisms, and 2 loaders manipulating heavy separate loading ammunition. If you stood inside and struck the wall with your hand, the thin steel rang like a pot lid. This turret resembled a metal shed more than a proper armored fighting compartment. Testing continued for about another year, collecting data that was to assist in creating the target vehicle FE-215 on the Conqueror chassis. Each test added to the understanding of the gun's behavior, its effect on the structure, and the system's tactical limitations. It seemed that, despite the difficulties, the British were moving toward a weapon capable of destroying any Soviet tank. But the project's end came out very differently. While British engineers were struggling with the problems of the giant gun, changes were occurring in the world that sharply altered the approach to countering heavy tanks. Military laboratories in various countries were actively working on a new category of weapon that promised to solve the problem of tank armor more simply, cheaply, and practically than any oversized gun. These were anti-tank guided missiles. These missiles could be mounted on almost anything, from light jeeps to armored personnel carriers, helicopters, and aircraft. Moreover, a single infantryman could carry a launcher and engage enemy tanks at ranges exceeding those of most tank guns. The cost of a single guided munition was a fraction of the price of a complex artillery system, and its effectiveness against heavy armor was comparable, sometimes superior. The key advantage of missiles was the ability to guide them onto the target. An operator could account for target movement, wind, and other factors, whereas the 183mm L4 gun had a serious accuracy problem at its maximum combat range of approximately 2,000 meters. The enormous heavy shell was sensitive to crosswinds, and correcting its flight after leaving the barrel was impossible. In real combat, where targets move and weather changes, this shortcoming could be critical. The year 1957 brought severe cuts to the British defense budget. Many units were merged or reduced, and expensive, contentious programs were cancelled. The FE-215 project, and with it the entire FE-4005 program, was officially terminated. Years of work, hundreds of hours of testing, an enormous expenditure ended without the vehicle entering service. The irony is that at roughly the same time, the Soviets were moving away from the cult of heavy tanks in favor of mass production of medium tanks. Instead of ever heavier and more heavily armored colossi along the lines of the IS-3, the emphasis shifted to numbers and mobility. Thousands of T-54 and then T-55 tanks were to fill any potential battlefield, not with supertanks but with mass. The threat that had caused tension at the Berlin Parade some 12 years earlier was losing its significance. Simultaneously, progress was being made in conventional ammunition. New fin-stabilized armor-piercing discarding sabot rounds were emerging, which provided excellent penetration from smaller and lighter guns. A 105mm or 120mm weapon with a modern ammunition family could produce results comparable to the giant 183mm gun, but without its size and recoil problems. After the program's closure, the FE-4005 prototypes were dismantled and the components dispersed. One of the Phase 2 turrets ended up at the Royal Military College of Science at Shrivenham as a teaching aid for students of military engineering. In January 1971, the Tank Museum at Bovington took in this turret, and it is probably the only surviving element of the entire project. For decades, the turret stood outdoors at the museum in rain, snow, and sunshine. Children climbed on it along with other exhibits until safety regulations became stricter. In 2007, the turret was mounted on a Centurion Mark 12 chassis and placed at the museum's exit as a gate guardian, where it stood for another 16 years. In 2023, a private collector of military vehicles named Joe Hughes became interested in uniting the FV 4005 turret with the correct Centurion Mark III chassis and returning the machine to running condition. An ambitious restoration project began. The engine, gearbox, clutches, and tracks were replaced. Every bolt and every component was cleaned, polished, or replaced with a new equivalent. If you enjoyed this story, give it a like and write in the comments which other strange and risky military designs you'd like to hear about. Subscribe to the channel and enable notifications so you don't miss the next stories about the most unusual machines in the history of warfare.